We remember about two planes, that is horizontal plane and vertical plane, and top view and front view. So generally you take any object, we can show that in different views. Before that we should know what is this 0 degree, 90 degree, right? This is what 180 degree, and this is what 270 degree. It becomes 360. Okay, this I'll write x and this is y. Fine. So from our school days we have studied, normally we have how many quadrants? Say 4 quadrants. I'll say this is my first quadrant, and should I go to the anti-clockwise or clockwise direction? Fine, it's anti-clockwise. You are sure about that? Because always we count the angle in terms of anti-clockwise direction, not the clockwise direction. You are all well versed because you have studied till +2. You know better mathematics, the basics. So you have to start from anti-clockwise direction. My first is my first quadrant, and this is my second quadrant. This is my third quadrant, and this is my fourth quadrant. Okay. Now these 4 quadrants we can easily draw it in a sheet, but in actual how it look like, I'll show as an example. Say for example, this is my first quadrant. Is it okay? My first quadrant is like this. Now second quadrant, how will I show? This vertical line is like this. Yeah, you all agree? This is my second quadrant. Okay. And my third quadrant, how to show? Again a vertical line, but it should be inverted. How? Like this. This is my third quadrant. Fine. And my fourth quadrant, how do I show? This same vertical line, it is inverted in other fashion like this. This is my, this is my fourth quadrant. This is an example. You all know this basically. I am just telling practically how it looks like. Because any object can be placed, say for example this chalk piece, this pencil, this CD cover, or anything can be placed in all the 4 quadrants. In the sense, I'll just take an example of first quadrant. We'll discuss about that. First quadrant is like this. Okay, and I told this line is a vertical line and this is an horizontal line. Now this vertical line is horizontal line. In the paper, how will you draw? Like this in the fashion, and if you turn like this, you are drawing it as simply this is vertical plane, this is horizontal plane, that we have already learned, like this. And I told you again, I'll make you remember, horizontal plane is tilted to 90 degree, then only it becomes a paper to draw the front view and top view. That you have to remember, always keep it in mind, very basic. Then now in this first quadrant, if I draw something, say for example I have this chalk piece here, the first quadrant. How do I define this? How do I explain that I have kept an chalk piece, an object, at what distance? Because everything is a dimension oriented. I told you basically, remember art and dimension. You remember I was drawing something, house and hut and all. It's an art, and dimension, drawing, it becomes a dimension. From my XY axis, at what distance I have my object is a question. How will I show that? Say for example this chalk piece, or I'll draw this a small a circle. This circle from this length, how it is from the ground, this is the vertical ground, it becomes some 8 centimeter, or an example of 8 centimeter height. And from the side, that means first quadrant, this is my vertical axis and my ground, this is with this one, bottom it is. From bottom I keep my circle, or this an object as a ball, you think, at 8 centimeter height. But from the wall or this corner, in what distance I should keep some distance, or either I can keep my ball joining with the wall, this vertical axis, or I should keep it in a different distance. Now this ball, I say this is a distance of, say suppose again an 8 centimeter or some centimeters you define, because any paper you take, what will you do basically? you draw the x-axis and y-axis. You indicate any diagram, say a circle. How do you indicate? This point you calculate as origination point, right? O. On from this you say, so I have traveled a distance of, say suppose 8 centimeter and drawn with the graph sheet. I can say graph sheet, mesh. It is a graph sheet. There you take 8 centimeter x-axis and y-axis some that is whatever the range it is. That's how we draw. The same thing I am explaining here. This becomes my first quadrant. In drawing, I will say this object, say suppose a ball or a circle, is in front of and above. I am using a common English word, in front of something, above something. Something in the sense, I have two planes. This is my HP. Kindly remember, I told you, this becomes my horizontal plane, vertical plane. Actually it is like this, vertical and horizontal. Now, I'll say this object circle is in front of vertical plane or in front of VP. You all agree? It's an image. You just think first quadrant is this, horizontal is this, vertical is this, right? Actually you are drawing it paper like this. When you tilt it, it becomes a paper and you are drawing it. This is the board. So actual case is like this, first quadrant. So in front of VP is my circle. I'll say one more, and an added step. In front of VP 8 centimeter, my ball is placed. Right? Now, at what distance from the bottom, from the ground, I have to check, because what is one object? As to say, from vertical it is 8 centimeter, and from horizontal it is another 8 or 6, whatever I fix. So it is in front of VP 8 centimeter, above HP, because it's HP line. HP, it is 8 centimeter. This is how I explain. So I'll write the in front of, I'll say IF, in front of this VP, IF VP. You please understand the expansion of this, in front of VP, and above, I'll let A, simply a first letter A, above HP. Any object you consider in first quadrant, it will come only under these two options. It will be only either in front of VP or I can say and above HP. Or even you can say, sir, this ball can be placed it here, sir. What is wrong? Correct. What will happen? It is on HP, again in front of VP. You get me? And one more placement. As you wish, you can draw in different, areas. You keep this ball. I'll put this ball here. Now what happens? It's touching both VP and HP. I can say ball is lying in a place where both VP and HP. There's no difference. But exactly to say, any object you place, it has got some difference value from this 0, 0 point. This 0 point, 0, 0 point. 0, 0, because anything you define in terms of x and y. You cannot define any object without meaning of x and y. It is sense, it's just common sense. You can say. So fine. Now I will say this is in front of and above HP. Very important. Now you come to the quadrant number 2. How will you define? I'll draw another ball here. The distances you can say, you put 1 centimeter, 5 centimeter, 10 centimeter, it's left to you. Fine. Now how will you define this? It is behind VP. You agree? Back side. Now, don't say back of VP, it is behind VP. B, behind. Or you write normally behind VP. I am writing the abbreviation, please. This is the original word. I am writing the abbreviation. It is behind VP. Again, how do you say? Again, yeah, correct. It is in front of, it is not in front of, it is behind VP, about HP, again above HP. Is it okay? This is in front, behind VP and above HP. Then come to third quadrant. How will I write? You talk about again VP. Behind VP it is again? Yeah. Behind VP and it is below HP. Is it right? B means behind or below. It is below here. Below HP. Then come here. What will happen? it is in front of VP again, in front of VP, and it is below HP or BHP. So only these four possibilities is for any object to draw. You will have only these four quadrants in general. That's what we have. We don't have something called fifth quadrant, right? So only four quadrants, and options are only in front of VP and above HP becomes first quadrant, behind VP and above HP becomes second quadrant, below VP and above HP, sorry, behind VP and below HP becomes third quadrant, in front of VP and below HP becomes fourth quadrant. So these four quadrants you can place any object. For example, I am talking about the topic projection of points. Projection of points, right? Any point. So that's why I just want to explain in terms of this corner, this pencil. This is a pencil. You just consider only this point, okay? This point alone, I can fix it anywhere. In my first quadrant like this, a point. My second quadrant means I'll be turning like this, a point. Third quadrant means become like this, yeah, a point. Fourth quadrant again become like this, a point. Is it okay? Fine. So what will happen? All the four quadrants, I can place my point and draw that. It becomes a projection. One more example, if you go to the realistic picture, I have to draw this XY line. That means basic XY line. This is my vertical plane, this is my horizontal plane. In this, say for example, I am placing this point. Say I will be just placing this point here, first quadrant here. Consider this is a point. I'll say one, I'll just tell about a question. A question what? A point A which is 10 centimeter above HP and 15 centimeter in front of VP. Okay? A point 10 centimeter above HP and 15 centimeter in front of, what is that? VP. How will I draw in the sketch? Actually we have to immediately come to a conclusion that we are talking about quadrant number 1, because we basically know in front of VP and above HP means it has to be only quadrant 1. Okay. Now how will I show this in this diagram? That's the sheet, because you are drawing in an A4 sheet. Normally your notebook is an A4 sheet, right? So a point A, I'll just give a point A is 10 centimeter above HP. From this line, is this VP HP. Above HP, this dimension shows a 10 centimeter. 10 centimeter. And what is this one? 15 centimeter in front of VP. In front of VP it is 15 centimeter. Where to show that? See, this point is like this. In the front view I told you can see whatever in the front view you are drawing it in the wall. That is VP. But these points, top view where to come? You have to think again. Basic class, as I told you, your eye has to come here. Your observer has to be on the top and see this and draw it in the bottom only. Just put top view. So your 10 centimeter above HP can be seen from this bottom above HP. You written 10 centimeter here. 15 centimeter in front of VP is a question. Okay. In front of VP, how will you show? Actually VP is here. In front it is 15 centimeter. Somewhere here it is. So this distance can be viewed only through top view. Fine. So you view it here. I'll say 15 centimeters is bit, this is small, 10 centimeter. 15 will be like this here. See, kindly remember, point is only one point. We don't have 2 points here. Point is only one, but it has got a distance of 10 centimeter from above HP and 15 centimeter in front of VP. Is it correct? What will happen here? 15 centimeter in front of VP. Same point, it is A, 15 centimeter. Is that right? Yeah. Now, what will happen is, basically, this 15 centimeter and 10 centimeter are the indications of the placement of the point, where it is placed in two views. In the front view, it is placed 10 centimeter above HP, and in the top view, it placed the distance of 15 centimeter. Now, you have to connect these 2 points with a small line. Why? This is an image. Image in the front view is this and top view is this. And again I told you what is this line is called. Somebody can tell me? This is nothing but a projection line. Hope you all remember projection line. Yes. Fine. Now this is A, and you see when you have 2 points, I mean same point at different front and top view, you have to at least indicate by different notations. Yeah, you should not write both A and A. This doesn't make any difference. You write this is this front view, whatever you write as A dash, and top view write as A and leave it as it is. Why? Because whatever you see in this direct front view is called pictorial view. What is pictorial? Nothing but picture. Whatever we see, in the front view, it becomes a picture, direct on eye contact. But top view is something, you should imagine that you are an observer going to the top side and seeing an object. Yeah? So this, whatever you see in the front view, you just write it as a dash. Okay, you can write it as, just in, I am using a different notation to understand. Front view looks by dash and top view looks by without dash. That's all. Is it okay? So that way it is front and top view. This is about a placing an object or a point in quadrant number 1. So like this we have to see quadrant number 2, number 3, number 4. This is only for points. And before going to 2 and 3 and 4, I would like to say, in the syllabus, I mean in the engineering drawing syllabus of first year, that is your syllabus, we are studying only about first angle projection. Right? The prescribed syllabus is first angle projection, in which we are bothered only about this first angle. I mean first quadrant. Everything is placed in first quadrant. In different manner it is in first quadrant. We are not talking about or reading about second, third and fourth. But to understand the projection of point, we can have some different questions like this. One question says point A is 10 centimeter above HP, 50 centimeter in front of VP, becomes first quadrant. Now you can ask, sir, you can change it, this 10 centimeter, below HP, and this 15 centimeter in front of VP. Which quadrant comes now? Can you tell me? Same thing, it is 10 centimeter below HP, 15 centimeter in front of VP. Where which quadrant? It is in front of VP and below HP. It becomes a fourth quadrant. Very simple. That you can again point it here. How will I point it here? Actually, to speak, I'll extend this line. So this becomes my one problem, it is over. The second question, I'll show a point, again, okay, I'll change this notation as point B. A point B which is placed at 10 centimeter below HP, BHP, and 15 centimeter in front of VP. So you should understand, it is below HP means this place, and in front of VP means it becomes fourth quadrant. Right? Now how will I place this? Again think, you can think it anyway. I will show it in terms of this CD. This fourth quadrant looks like this. You agree? It is 10 centimeter below HP, somewhere here. Yeah, and 15 centimeter in front of VP. This VP 15 centimeter here. So I can see in the front view what? From the front view you see this VP. In front of VP it is 15 centimeter. Yeah, 15 centimeter. That you can draw. Where will you draw? in front of VP 15 centimeter. You have your VP here and HP here. In front of VP 15 centimeter means this part where you can see in either by front view only. In the front view, where will you draw it actually? That you have to draw it here. In front of VP is, how much is given? 15 centimeter. Just 15 centimeter. Okay? Because kindly remember, if when you come to fourth quadrant, HP is here and VP is here below. In front of VP is like this. And 10 centimeter below HP. Again below. Where will you see this below? It is 10 centimeter below. How will you see this? Again front view. In the front view, how will you see? It will become actually this place is in front of VP and below HP is this. It will again come here. I can say this point B, this 15 centimeter and 10 centimeter at this place itself. Same point here. This becomes 10 centimeter. So this point is same line, but it comes only under this. This is the category of your fourth quadrant. That's very important. Like this, you have different quadrant number 1, 2, 3 and 4 in different manner. That will be okay. That's fine.